waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Chapter 10, Section 1. Chapter 10 is on circles, and this video particularly is about properties of tangents. We're also going to talk about some of the basic vocab for circles. So the first word, obviously, is circle, which is the set of all points in a plane that are equidistant from a given point called the center of the circle. So the center of the circle is how we name the circle. So this would be circle A because the center is called point A. And so a circle is the set of all points that are equidistant from that point. So in other words, every point on this circle is the same distance away from point A. And so all of those points are equidistant, and that's what makes a circle. Radius is any segment whose endpoints are the center and any point on the circle. So basically what I just drew above was the radii, which is plural for radius. So if this is circle A, this is a radius. Why? Because one of its endpoints is the center A and the other endpoint is on the circle. So anywhere you draw a segment from the center to a point on the circle, that is a radius, and those distances will always be the same. So you need to really understand that the radius does not have to be straight across, like horizontal like that. The radius can be anywhere from the center to an endpoint on the circle. A chord is a segment whose endpoints are on a circle. And so what this looks like is, this looks like a segment starting there and ending here, for instance. Why? Because the endpoints are both on the circle. I could draw another chord from here over to here. I could draw a chord from here to here. Okay, now notice I haven't labeled the center of my circle. If I put the center of my circle here and call that A, then the chord that goes through A is going to be a special type of chord that we're going to talk about in just a second. But a chord is any segment. Notice it's a segment, which means it has two endpoints, a start and an end. The diameter is what I just talked about. The diameter is a chord that contains the center of the circle. So again, if this is circle A, then my diameter is going to be from one endpoint on the circle through the center to another endpoint. And again, there's multiple ways that I can draw this diameter. It doesn't have to look a certain way like you might think. I mean, look how many times I can draw this. Always going through the center with endpoints on the circle. That is the diameter. A secant, that's how you say that, secant is a line. What is a line? A line has no endpoints that intersects the circle in 2 points. So for example, this is a secant. It intersects here and here, but it is a line, not a segment. That's the main difference between a chord and a secant. A chord is a segment, a secant is a line. That's really important. So I could draw another secant here. I could draw a ton of secants, again, intersecting at 2 points. Our last real vocab here is tangent. Tangent is a line, again, a line, so it does not have endpoints, in the plane of a circle that intersects the circle only once, exactly 1 point, and that point that it intersects is called the point of tangency. So if I put this point here, let's call that point B with the center of the circle being A. The tangent line goes through B, and I know it looks like it crosses the circle more than once, kind of the way I drew it. But you need to understand is that this line, we'll call this line CD or CB. Line CD intersects the circle A, only at B. It does not intersect anywhere else. And that point B is called the point of tangency. So the point of tangency here would be point B. All right, so coplanar circles. So if I have two circles that are in the same plane, there's 3 different ways that they can intersect or not intersect. So in this first example, there are 2 points of intersection. So it kind of looks like a Venn diagram. So the points of intersection are there. In this example, there is one point of intersection. These are called tangent circles. So the points of intersection are, for instance, here, again, that it just touches one at one point, or here, it just touches at one point. And then the last one, those are called concentric circles, and obviously they are no points of intersection. So those are the three different ways that you might see two circles in the same plane. Okay, common tangents are tangent lines that intersect two circles. So it's one line that is tangent to two circles. So for example, I'm going to do the best I can here. So it's going to tangent there and it's going to tangent there. Okay, so here is a point of tangency on that circle and this is the point of tangency on that circle. So there's one common tangent. Another common tangent would be right here. Again, doing the best I can here. Tangent there and there. I could also do a common tangent up here. Again, doing the best I can. I know that's not too great. And also down here. Okay, so there are 4 common tangents in those two circles. Again, a tangent that is tangent to two coplanar circles. Okay, so the tangent line is tangent to two coplanar circles. We have a couple theorems we need to know here. The first one says, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius. So what does this look like? So if this, again, is circle A, remember the radius is the segment that contains the center and any point on the circle. So I'm going to just draw a radius right here. So we're going to call that point B. So segment AB is the radius. And so a line is tangent if and only if it's perpendicular to that segment. So what does that mean? That means if this is the line of tangency, if this is the tangent line, so we'll call this line CD. Line CD is tangent to circle A at point B because the measure of angle ABD equals 90 degrees. In other words, it has to be perpendicular. This has to be a right angle. So if you know you have a radius and you have a tangent line, then that is going to be a right angle. Now, if you're not sure if this is a tangent line, then you can check by seeing if it is a right angle. How could you see if it was a right angle? Well, possibly you could use a right triangle. So if that's a right angle, then what I just kind of drew here would be a right triangle. You could also draw a right triangle this way. So you can use right triangles, and we'll work on that in class. The last theorem here, tangent segments from a common external point are congruent. Okay, so this is point A and point B. Those are the points of tangent C. And this out here is point C. And so both of these tangent segments, segment BC and segment AC, are tangent lines, and they share this endpoint C. And because of that, AC, segment AC, is congruent to segment BC, which means the length of AC is equal to the length of BC. Remember the difference between congruent and equal. Okay, segments are congruent, lengths are equal. Remember, this means length of AC, which is a number. Okay, this means the length of BC, which is a number. So if you have tangent segments from a common external point, external meaning outside the circle, then they will be congruent.
I've been waiting way too long. Yeah.